Welcome to Big Data on Brews, today with Milind Bhandarkar from Pivotal. Milind, can you introduce yourself and the wonderful brew you brought with you? I'm super excited about today's brew.
All right, sure. So I'm Milind Bhandarkar, and I'm the chief scientist at Pivotal. So the beer today is actually from my native place in India. Kingfisher is a huge alcohol empire in India. Now they have diversified. They have an airline also.
I was going to say that. They even have, it's my favorite. I want to fly with that airline.
Right.
I don't know why the German breweries don't have airlines here.
So yeah, that's what it is. There are a bunch of other brewing companies, but I think Kingfisher is the most popular in India.
It's the most popular with me. If I can, if I go somewhere and they have different choices, I would rather go for Kingfisher than for an American beer.
Right.
Because it's a very much kind of a lager style beer.
Yeah, it is.
Oh, and it's so good and refreshing.
Right. Earlier, I was trying to make a decision whether to bring IPA, but I tweeted about it, and
you know me long enough,
right?
Oh well, yeah. I'm very
because
excited.
IPA also has a connection with India. They had to make it stronger in order to, because beer was never manufactured or brewed in India.
Okay.
So when British ruled India, they used to get all their beer transported from Britain all the way to India.
But they only have miserable beer.
and in that transport, the fizz will lose out.
Right.
The alcohol content will go down. So they had to make it. So India Pale Ale actually is extra hoppy.
Yeah,
exactly.
Yeah.
Exactly. So I
right.
said, okay.
Well,
8% alcohol versus 5%. I would go with 5%.
It's just like a real. You can look through it.
Yeah, absolutely.
Cheers. Well, thank you for coming.
No problem.
So just really good and refreshing. Okay, people. Tell me a little bit more what you do at Pivotal.
So as a chief scientist, basically I look out 2 years or maybe even 18 months in future as to see what all technologies are out there that are making an impact on this whole big data space in general. And I basically sort of like a strategist, I pave the direction towards moving towards that technology. So just to give you an example, been looking at Spark for almost 2 years now, since it came out of Rad Lab and then Amp Lab, and really trying to see, what are the use cases for Spark in our big data stack, and how we can actually integrate Spark to not look different just as yet another project running on the Hadoop distribution, but really integrate within the end-to-end data workflows that most of our common use cases are the distribution gets used for. So that's the kind of things that is my day-to-day job.
So Pivotal has a kind of a unique situations given kind of the big backing, the big company, and a lot of kind of historical technology, the Green Plum.
That's right.
Technology, and of course the Green Plum experience. So what are the components in the mix that makes Pivotal so strong and in this certain areas, and where are the advantages?
Sure. So whenever I go and talk to customers, I basically say, our Pivotal Hadoop distribution is just about a year old, but the products in there have a long history, and they're not just 1 year old. So the two major components of the Pivotal Hadoop stack today are Hawk, which is essentially Green Plum database running on top of HDFS, storing data natively within HDFS. And the recent one that we announced is Gemfire XD, which used to be called SQLfire, which is sort of an in-memory SQL processing engine. So moving that to do its persistent storage on top of HDFS as well.
So you have the super fast 10-year super mature SQL engine with Green Plum in there, and now you have that kind of maybe a Storm kind of, but more mature in-memory SQL?
It's yeah, exactly. So in-memory SQL. So it actually came out of a company called Gemstone, almost 12 years old. That company, which was acquired by VMware in 2010. So they are in a couple of spaces. So the space of in-memory data grids, IMDG, that's where they primarily came from. And they saw the storage engine that was built as an IMDG, if we could implement a SQL front end to that. So they essentially implemented a SQL front end that stores the data in Gemfire. So Gemfire was the original IMDG, the in-memory data grid engine. So we took that and we basically replaced its persistent layer, which used to use only local disks, which basically means on failure, you basically have to replicate and all these things. We replaced that with HDFS. Now the use cases that are enabled by such an architecture is that you have your high-speed data ingestion coming in, right? That gets straight away into SQL Fire. For the first 5 minutes, 10 minutes, as long as the data sits in memory, you can actually query it at in-memory speeds using SQL as it comes in,
that's awesome.
right? And then as that data ages, that data then basically gets onto the persistent store.
So you maybe have even multiple layers. You have a super hot layer, you have like a warm layer.
And then the cold layer. That's basically the
So the hot layer is in memory, and then the warm layer is what?
It's actually directly in HDFS.
Oh,
in fact, there is actually a local disk layer as well. So that we haven't ripped it out. But the local disk layer, there is an asynchronous event queue listener listening on that layer that puts it onto HDFS. Cool. So within maybe a few minutes, that data gets onto HDFS, which then becomes queryable not only by Gemfire itself, but also by MapReduce, by Hawk, by whatever technologies you have, right? Which is actually querying the same data. So if you see the theme of Pivotal HD, it's basically bringing all these data sources into a single. Now the marketing term is called data lake. You call it data dump or data repository, or whatever you want.
No, I disagree. It's not a lake. It's not an ocean, even though our name is Data Ocean, right? I would argue it's a data river. Because,
data river, it's flowing.
There are there are springs, and there are many small springs. There's your mobile app, there's your social marketing, there's your log files, and they flowing together and forming, maybe rivers. And eventually it becomes the Colorado River.
Right. Okay.
That's the way, right? And then eventually, people build
dams,
water power.
Dam. Yeah, exactly.
And this is where you extract the value. Here's where your ROI is.
I like that analogy.
I think the interesting thing about this is that you have kind of multiple dimensions to that, right? You have location. With this, right? You need to transport the data because it's somewhere here, and eventually the big power is over here. But you also have you have time with this as well, right? The data is generated. How fast do you get it over here? Or the road? So anyhow, the new coin choked by me, data river.
Okay. No, but it's interesting. You say springs here, right? This is the layer at which data gets ingested. So another part of the whole pivotal Hadoop stack is actually Spring XD. Which is
I didn't mean this Spring though. I mean a water Spring
as a
data
framework.
Spring. But I'm a big fan of Spring. I mean, I even a fun fact. I worked at JBoss for a while with the whole Hibernate and the Spring integration. The good old times where Spring was the killer of G2E.
Right.
I wonder what the killer of. Maybe Hadoop is the new old G2E, the heavy, a lot of implementing. They were kind of maybe,
People won't like to put it in this way, right? The flexibility that Hadoop actually provides you, I would say the old large data warehousing platform, that's more of a J2E that the flexible Hadoop is trying to encroach upon or reduce.
Every time I say same thing, I'm missing a version of control. That was kind of the big breakthrough for Spring. If Hadoop would have inversion of control, we would be already 5 years ahead because we could block storage system, transport, we could execute. Well, we kind of getting there half-hearted with Java. Anyhow,
story. but the refactoring or the re-architecting of Hadoop, right, is I think slowed down because of the maturity of use cases, especially in the early Web 2.0 companies, right? I mean, having to change interfaces or improve APIs in Hadoop actually became bogged down in this several month-long upgrade cycles at
of course.
Yahoo.
Yeah, because it was an inversion of control from the first part, where you could just say, well, okay, I execute what you can now do with Yarn. Again, I think we go in the right direction. Where you say, oh, I want to run this on MapReduce 2.0, on MapReduce 5.0, right? And you can just plug it in.
Correct, exactly.
So, tell me a little bit more about what you did before Pivotal. I think we know each other for a little longer.
10 years now. 10 years, that's true.
So,
can't believe it's 10 years,
it's
right?
Unbelievable,
it's unbelievable,
right? Yeah. Like Hadoop made me all this gray hair, so I didn't have gray hairs 10 years ago.
Same thing. That made me laugh. I mean, I actually jokingly say, upgrade at Yahoo from Hadoop 0.18 to Hadoop 0.20 made me lose half my hair.
I can see that though. That was a big thing.
That was a big thing. So we got rid of Hadoop on demand and we went to the new capacity scheduler.
Right.
Oh, that literally resulted in
you already said you worked at Yahoo, but tell us a little bit more. When did you join Yahoo? How long? And what part did you play there?
Sure. So actually, I would divide my career into two halves, right? Almost equal halves now. The initial part, I would say, from 91 to 2005. It was mostly about high-performance computing, right? After graduating from India, I was fortunate to work on a project that the government of India had launched under Department of Electronics there to build the first indigenous supercomputer in India.
Oh, wow.
Because the weather department, they could not get, because there were export control on how much US could export in terms of computing hardware.
Interesting.
So the sale of Cray, I believe it was XMP at that time. Cray XMP was blocked by the US government. They could not sell it to India. So Indian government started their own project. They basically said, okay.
The Gray wasn't that. I mean,
Cray,
it was the best thing you could buy for money, but it wasn't great if you look back. No,
I mean, if you look at it, right? I mean, yeah, that was one of the first, very innovative supercomputer and things like that. But if you look at the amount of compute power that it had, it probably is, much less than my laptop today.
Yeah,
right?
It's amazing, right?
It's amazing, right?
Oh.
So I worked for a couple of years on that project. We built our team built a first supercomputer called Param in India. And at that time, after that project finished, I was, okay, where do I go next? So I came to the United States, University of Illinois at Urbana-Champaign to do my PhD and in parallel computing. And so I spent 8 years there, too long, but to do my PhD. But so 2002, I graduated, and I was getting tired of academics, having to write all these research proposals for, getting NSF grants and all these things. I basically just took a complete U-turn and said, 2002, I'm not going to have anything to do with research. And at that time in the Valley, there was only one company hiring, which was Siebel Systems. So I joined Siebel to do their application server, load balancing in application server. I spent 1.5 years there and joined a startup called PathScale, and we actually built a message passing system on top of InfiniBand. And so 1.3 microsecond latency, user space to user space.
Nice.
Between
in
two
2000
machines.
And
this was 2003.
Oh.
2003, 2004.
Nice.
As I was winding down that project, an ex-colleague of mine, actually he was a grad student at University of Illinois as well, Samir Paranjpe. He was at Yahoo at that time. And he basically said, hey, we are launching this project with Eric. We are going to revamp the entire search content engine backend.
Yeah,
right?
And it happened to be a few tens of thousand computers. Do you want to be part of that?
At that time, it was around 2,000. Let me remember. I think it was around 1,000 machines running the web map itself.
Yeah.
Then there were some 3,000 machines.
Huge.
Yeah, that was huge.
I'm like, I want to have 10 minutes on those machines. What I could do.
Then there was a Echelon project doing indexing, and then there was obviously the search engine. All combined, there would be something like 6,000 to 7,000 machines, right? Doing that at that time. Basically says, okay, when do I get my hands onto this machine? And basically, I joined Yahoo. So we started working on a project called Juggernaut. Juggernaut was essentially, okay, the Google MapReduce and GFS papers had come out. Why doesn't Yahoo have an infrastructure like that? So
Eric talked about that a little bit.
Right, exactly. Yeah. And I was the first one hired from outside of Yahoo into that team. Eric and Samir were sort of managing those teams. Owen was the first one to join. Second one was me.
But Owen was already in Yahoo.
Owen was already working on WebMap.
NASA and then Yahoo, right?
Yeah, he was already working on WebMap at Yahoo at that time. So he was a transfer.
Is rocket science.
It is rocket science, absolutely.
Based on Owen.
So Owen moved from NASA. In Illinois, I used to work in a center called Center for Simulation of Advanced Rockets.
Oh.
So the first two hires into the systems were actually had a rocket science background.
All right.
I mean, I did not understand rockets. I basically just, tell me what programs to write, and I'm going to write those in parallel.
Wow, I didn't know that.
Interesting. Amazing thing. I mean, first 6 hires into that team, 4 had PhDs. Okay, Konstantin Shosko, Hairong Kuang, me, and Owen. Right. So you can basically see it was a very sort of rocket sciencey stuff. That it was an advanced science project that we were running in there.
Yeah.
But it has been an amazing ride. I was there for 5.5 years. I contributed some initial work at in Hadoop. I think my first patch went in 0.1 or 0.1.1 or something like that. And Hadoop Record IO, the whole serialization system that was, I think, still is used in Yahoo. So that was my doing. And then the one that I'm most proud of, the one that came from a project called Jute, by the way. So as part of this Juggernaut, we actually started building a Juggernaut MapReduce, which was primarily Owen stuff.
Yeah.
JFS was Konstantin Shosko and Hairong. And I was working on a project called Jute, which was, I like to come up with names. So it was Juggernaut Utility Table Environment. Okay. So that's what Jute actually stood for. And we basically said, okay, let's take this and it was actually the full-fledged project was supposed to do the whole columnar layout in the JFS, Juggernaut file system. Yeah. So after we adopted Hadoop in December 2005, basically said, okay, let's take the serialization piece of Jute that we have already built and let's move that under Hadoop as a Hadoop Record IO. So that was my doing. And the one that I'm most proud of is actually some code that I wrote in order to debug an issue in HDFS, which is the Pi estimator program.
Okay.
So the initial version of the Pi estimator, so you start a Hadoop cluster and basically say, okay, is it up? Let me submit a Pi estimator example. So that's my doing. Nice. So that's the one that I really like.
This is still run today, right?
It is still run today.
And people
it's actually changed a lot now from the initial versions. I think Chris Douglas took a stab at it later. And someone else, Nicholas Zay, he also took a stab. I think Nicholas is the one who has completely rewritten it.
Did someone discover more pi numbers with your program?
That was Nicholas. That was the running a Hadoop MapReduce program in order to find a particular digit of pi.
Yeah.
So he like using some 1300 or something like that machines or 1500 machines, he discovered 2 billionth digit of pi or something like that. There was a lot of discussion on Devil Random, which used to be the Yahoo internal mailing list about that. That is this really a good use of our clusters,
of our hardware,
finding digits of pi?
Okay. You made it into the books, right?
Yeah, exactly.
Great. Well, we will come right back and talk a little bit more about the good, fun old times, and then learn a little bit more about what you do at Pivotal today.
Sure.
Well, thank you for joining.
Sure. Thanks for inviting me.